to another video. Today we are going to be looking at taking off superstructure works. You will be given a plan in a section and you'll be told to take off all superstructure works that are there. So you are supposed to take off the columns, the beams, the suspended slab, because in this case it's a flat roof. Then you'll do the roof finish, the parapet wall, and the Pcc coping together with the rainwater goods. So whenever you're given any takeoff to do, we said that you first study the plan and the section so that you can be able to know all the details that are involved. So in this case, in this plan, we can see the plan here. It's a roof plan because it involves a suspended slab. The roof of the house is the suspended slab. So it has the walls, the beams, the columns, then at it is a suspended slab. On top of the slab, there is the parapet wall that holds the Pcc coping. So let's look at the plan and the section so that we can be able to understand the drawing. So here we can see this one is the columns. The columns, they are 200 by 200 millimeters thick. Then this one is Pcc coping. From the top, we shall see Pcc coping. What is a Pcc coping? The Pcc coping, when you have the house here, assume this is a house. It's a house. It's a rectangular house. Assume this is now the house. On top of every wall, this is a wall. In a flat roof, we have this section. This is the wall up to here. Then there is this extension of the wall here, this small wall at the top of the roof. This one is usually called a parapet wall. That small wall that is on top of the slab. On top of this wall, there is something protruding here, like a small slab that prevents water from, when it rains, running down the walls. That one is called a Pcc coping. If we were to look at the section, you'll be able to see it better. If this is the wall of the house, and this is the slab, this is the wall, this is the wall of the house, this is where the slab lies. Now here, there is a small wall on top of the slab. This is the parapet wall. On top of the parapet wall, there is this small slab which is bending at an angle. It's called the Pcc coping, so that when it rains, it doesn't rain on the wall. The water falls to the slab. It is directed by this Pcc coping. So when you look the house from above, the plan view, you will be able to see this Pcc coping, and it's wider than the wall because its work is to protect the wall from the water when it rains, so that it can land on the slab. I hope that is understood. So let's go back to the plan. These are the columns, 200 by 200 millimeters column. Then the Pcc coping, it's the one that we shall see from above, 300 by 75. 300 is the thickness, it's the width of the Pcc coping. 75 is the thickness of the Pcc coping. You know, they are very thin, because their work is only to protect the wall. Then below the Pcc coping, you can see this dotted line. It's the wall that is beneath the Pcc coping. So it's 200 millimeters thick concrete block wall. Why it's dotted? It's because we cannot see it from above, but we know that it is below the coping. Then here we have the 100 millimeters diameter Upvc full borer rainwater outlet. This one is the pipes which are on the slab. They are on the slab so that they can be able to take the water down. If we look at the section, it shall be able to show as well. You see here, it's the Upvc rainwater outlet. When it rains, water is directed to the slab by the Pcc coping. Then when it lands on the slab, the water cannot stay here. It needs to be drained downwards by the down pipe. So it will come and exit through the Upvc rainwater outlet. So that is understood. So so these are the walls. The walls are coming this way, and above the walls we have the beams, because we have to have the beams so that they can support the slab. So how many columns do we have? 1, 2, 3, 4, 5, 6. Then we have the beams all around where we have the dotted lines, which are above the walls, below the suspended slab. So the width of the building is 400, 4500, and the thickness of the walls are 200. What about the length? The length we have 3500 from here up to here. Then the thickness of the wall 200. Then this one is 3500, the thickness of the wall 200, and here it's 200. When we come to the section, let's see the section. Let's study the section so that we're able to understand. Here we have the asphalt finish, 30 millimeters thick asphalt finish. We said that the work of the asphalt is to make the slab waterproof, so that when it rains, the water cannot go down to the house. So asphalt makes the slab very waterproof. So it's the last thing that is done on the slab. Below the asphalt, we have the screed. The screed, which is done on the slab. This is the slab, 150 millimeters thick concrete slab, 1:2. So this slab is the one that is on top of the beams. You see the beams here? These are the beams. Then we have the slab. Then we have the screed on top of the slab. Then we have the asphalt. All the asphalt is to make the slab waterproof. Then the screed is the finish to the slab, so that when it rains, water is directed to the UPVC water. Then it comes rainwater outlet. It comes down through the down pipe out through the shoe to the ground. So here we have the PCC coping. As I explained, this is the coping to protect the walls from the waters. Then we have 200 millimeters thick concrete block wall. Here we have the wall, the parapet wall, which is situated on top of the slab. Pcc Coping. Yes, the work of this wall is to hold the Pcc Coping, and also to protect when the water rains, it doesn't come out, it doesn't run out to the ground. It is directed to the UPVC pipe. Then we have the slab. Then here we have the beam. The beams are here. You see, they run like that. Then we have the 200 millimeters. This one, it's the walls. This one is the wall. This is a wall. This is a wall. Then here we have the down slab. The slab are on the ground floor. Then here it's the ground level. Remember, we usually do the slab just above the cushion. This is section AA, which was cut from here across here. So now we have studied the plans. Now, so what is the procedure that we shall use to take off? We always, whenever we do a takeoff, we need to have the checklist. The checklist, and now here it's our checklist. We shall say take off superstructure works. The checklist will be: 1, we shall take off the vibrated reinforced concrete. Where is the vibrated reinforced concrete? 1 is in the columns, then we have them in the beams, then we have the concrete in the slab. Then we shall take off the formwork. We shall need formwork for the columns. For the columns is whenever we have a column all around the column. Here we have a column. The columns are normally, in a normal case, they are rectangular. Assume this is the column. We usually do formwork here. Then in case we have another one all around, this side, this one, and this one, we do formwork. Then we do the reinforcement inside. Then we fill in the concrete. So the formwork we shall be taking off in columns, they are on the sides of the columns. If it's a beam, the beam is like this. Maybe it's like this. We need to do the formwork to hold the formwork. Here there are stones. It's a stone walling. So here we shall not need the formwork, we shall do it at this side, then this side. On top, we shall fill in the concrete. We shall take off. If in case if it's a slab, the slab is like this, we need to do formwork on the soffits, yani below the slab, and also at the edges, so that it can hold the concrete. So let's start. We go to wall. Walling, we shall do the walling, then we shall do the finish to the walling. The roof, we have already done the slab, so we shall do the screed on top of the slab, then we have the asphalt, then we do the skirting. The skirting is that when we have a slab here, even in houses we do skirting. When we have the floor, and here there are walls, when we have walls, even in your house, you can check, there is that extension that we do. If we are doing tiles here, that small extension that we do for tiles all around the house, so that you can see when on the floor we have tiles, now we have some small tiles on the wall, just some minimum, so that when the tiles get dirty, there is a likelihood of the walls getting dirty to some extent on the walls. So that extension is usually called skirting. Now in a roof where it is flat roof and it's raining, the water will come to the slab. But because we want also to protect the walls, the water may extend to some extent to the height, we will also do some asphalt on the walls. Now that allowance that we give to the walls for the asphalt and screed is called the skirting. Now, parapet wall. We say that the parapet wall is the wall on top of the slab that usually holds the Pcc coping. The Pcc coping is that slab on top of the walls that protects the walls from the water, so that the water is directed to the slab so that it can be drained using the Upvc water outlet. Then we have the rainwater goods. It includes the downpipe, the one that will direct the water down. Then we have the extra over for the shoe. The shoe is this part in the section. This part is called a shoe for directing the water. It's so that the water doesn't come directly down. It's directed towards the drainage. Maybe the drainage is here. So this one is the shoe. Then we have the full borer. The full borer is this part. This part. Now let's start taking off. When we are taking off, we have said we shall use the checklist. Now we come to the first item: vibrated reinforced concrete in columns. What are the measurements? Because takeoff it's about measurements. We shall come and count how many columns we have. How many columns do we have? They are 1, 2, 3, 4, 5, 6. 6 columns. Then we shall write here 6 times. Then what are the measurements of the column? The measurements of the column, they are 200 by 200 columns. So we have 6 columns, they are 200 by 200. Then what is the height of the column? You see, the column is like this one. So the column is 200 by 200 by that 600. The volume of the concrete that will be in the columns will be length times width times depth. So it shall be length is 0.2, width 0.2, depth, the height of the column 3.60. How many columns? 6. So 6 times length, width, height of the columns. Vibrated reinforced concrete, ratio 1:2:4 in columns. So have we got this one? It's on from the drawing. This one. Now we go to the beams. The beams, we count how many beams we have and the measurements. In the drawing, we have this beam here, we have this one and this one. Those ones are equal. How many are equal? 1, 2, 3. What are the measurements of the beams? The beams are on top of the wall. So they are 200. Then we have, they are 200 millimeters thick because on the wall. Then the thickness of the beams, where is it shown? The thickness of the depth length of the beam, the wall to here. This is the length of the beam. The width is 200, the thickness of the wall. Then the depth is this one. The depth is this part. So we have to move this part. This is the depth of the beam. So how many beams were those? 3 equal beams. So when you are taking off, it shall be 3 times 4.90, 0.2 for the width, the depth of the beams. Now there are other beams. There are these other beams which are here, from here to here. Here we have the column. Then we have another beam from here to here. So what is the measurement from here to here, from here to here? So what are the measurements of these beams? And how many? 1, 2, 3, 4. They are equal. They are 3500 millimeters length. The width is 200. What is the depth of those meters? The width, because they lie on top of the walls, which are 200 millimeters. Then the depth of the beams, 0.300 millimeters. So we have taken off the written above. VRC concrete ratio, cement, sand, mortar is 1:2:4 in columns. Now is ditto but to beams. Ditto is this concrete to beams. To the suspended slab. The suspended slab will lie on top of the walls. It shall cover the whole area on top of the walls. So what are the measurements? For the length, we shall take 200 plus 3500 plus 200 plus 3500 plus 200. 200 plus 3500, that's 700, plus 200, that's 900, plus 3500, it shall be 7400, plus 200, 7600. What is the measurements of the width? 200 plus 4500, 4700, plus 200, 4900. So it shall be 7600, 7.60, 4900, 4.90. Vibrated reinforced concrete, ratio 1:2:4 in 150 millimeters thick, suspended slab. Where did we get the description from? It's from this section. It is 150 millimeters thick concrete, ratio 1:2 slab. I shall scan this diagram, then you shall be able to download it so that whenever you're going through it, you'll be able to refer from it. Now we shall go to the, that one was the formwork for the suspended slab. Why was it below the slab? It's because the slab will be held by the formwork, which is below. Now we shall go to that one was for vibrated reinforced concrete. Vibrated reinforced concrete. Now that one, so we have found the volume of the slab, but for the slab, it's usually measured in area, in the SMM. So we have taken the length and the width, because in the SMM, columns and beams we measure in volume. That's why we have length, width, depth. Length, width, but for the slab we measure it in area. length and width. Now we shall go to the formwork. Formwork for the column, we have the column here, which we say that we shall do the formwork on the sides of this column. So what is the measurement of the sides? We shall take the thickness is 200 millimeters, the height is 3600. So the measurement shall be the length and the height. The length 0.20, 3.60. For how many sides? 4 sides. For how many columns? 6 columns. 6 columns from where? 1, 2, 3, 4, 5, 6. So it shall be 6 times 4 times 0.20, 3.60. Sewn cypress formwork to vertical sides of column. We go to the beams. The beams are usually like this. Where do we do the beams formwork? It's on the sides. So what are the measurements for the sides of the beams? Remember, we have 2 types of beams. These ones that are equal, then we have these ones which are equal, the 4 and the 3. So we start with the 3. For these 3 beams, what is the area of the formwork? It shall be the length times the depth. What is the length of the beams? The length of the beam we shall take from here at the edges, because the formwork will have to run from here up to here. So it will be 200 plus 4500 plus 200, 4900. What is the depth of the depth of the beam? This is the beam. So we shall take we shall account for the formwork even below the beams to support the concrete from below. So when we are doing the column, we shall measure the column, the formwork all around the beam, except for the top part where we shall put the concrete in. So what is the length of this formwork all around the beam? It shall be 300 plus 200 plus 300, that is 800. Then we shall multiply by the length of the beam. When we say the length, we mean this length, so that you can get the area of the formwork. So for the 3 beams, which are 1, 2, 3, the length of the beam, formwork of the beam, it shall be from here to here, 4900. Then the width shall be this perimeter around the beam. So it shall be 3 beams which measure 4.90 the length. The width shall be 0.80. This one. So we go to the other 4 beams. The other 4 beams, they are 1, 2, 3, 4. The length is 3500. Because the other, you see the column, the formwork was starting from here to here. Now, and the other one from here to here. So this other one will start from here to here. And this one from here to here. So it shall be, and you remember for this one, it was getting up to here. So the formwork that we want to account for, it's from here to here. That's where it's not covered. So it shall be the same 800 on the wind side, but on the length side, it shall be 3500. How many beams? 4 beams. So it shall be 4 times 3.50, 3.50 and 0.8. 0.8 is this one. So it shall be ditto is the sewn cypress formwork to vertical and soffits of beams starting 3.5 to 5 meters. What we mean here is Ditto is sawn cypress formwork to vertical. Vertical is here. The soffits, soffits is the down part of the beam. Strutting is the formwork that we shall use. You know, we usually join two bow timber. We join them here, then we do some strutting using some small strut. We nail here, nail here. You see, nail here, nail here. These are two separate timbers, so we join them using struts so that it can be like that one. To add the height, this timber should be a height between 3.5 to 5 meters. We go to the formwork of the suspended slab. The suspended slab, we shall do the soffits. The soffits, it's just below the slab. Whenever you're inside the room, when you look up, that part you can see of the slab is the soffits of the slab, the part below that you can see. Then we shall do them to the edges. For the soffits, how do we measure them? It is the internal dimensions. Soffits, it's that part of the slab, this one, from here to here, from here to here, here to here, here to here. That part which is not on the wall inside the house. So what is the measurements? The dimension. The length, for the length is this one, 4.5. Then from here up to here, 3.5. Then we multiply by 2. Because this one is a beam. That one, the slab will lie on the beam. So this one is taken care of. So the area that is not taken care of, it's from here to here, from here to here, from here to here. Remember that we are not using this line inside because this one is the Pcc coping. The walls, they are the dotted lines. So those ones are the ones that we are using. Now, we continue to the slabs. So we have said there are two slabs, two rectangles measuring 4.5 and 3.5. 4.5 from here to here and 3.5 from here to here. Then to the edges of the suspended slab where we shall do the formwork, it's from here to here and from here to here, the wind. So the formwork is usually measured in length. So what is the length of this formwork? For the length side, we start with the length side. It shall be that 500 plus that 500, 7,000 plus 272, 74, 7,600. So 7,600 times 2. This one, 2 times 7.6, because we entered. Then for the other side, it's here and here to the edges of the slab where we shall do the concrete. So it shall be 2 times 4,900. 2 times 4.90. We are done with the formwork now because we have already done for the column, for the beams, and for the slab. Now the next step, we should go to the walling. What is the length of the walling that we shall do? To find the area of the walls, because walling, we usually measure it in square meters. We shall do the center line of the wall, then we multiply by the height of the wall. What is the center line of this wall? The wall, you can see that it's coming all around. So what is the length of the wall? This one is 7,600. Then here we have the other one, 4,900. So we shall take 7,600. We add 4,900. We find the perimeter. Perimeter is equals to 2 into bracket length plus width. Then we add the so it's length 7,600, width 4,900. Perimeter is 2 into bracket length plus width. 2 times total of this one gets 25,000. The center line, you remember, it's coming, you walk katikati ya ukuta at the center of the walls, you go all round. So if the thickness of the wall is 200, where will be the center line? We shall come inside with 100. From here we come inside with 100. So for every corner we shall deduct 200 because it shall be here. It shall be here. So for every corner we shall deduct 200 from here up to the center, from here up to the center. 200 times 1, 2, 3, 4, it's 800. So the perimeter, we deduct 800 to get the center line. Then we do center line times the height of the wall. The height of the wall comes from the section. The section will be able to show us the height of the wall from here up to here, where the beam is starting, is 3600. So that is the area of the walls. So for the description, it shall be 200 millimeters thick wall, bended and jointed in cement sand ratio 1:3 mix. And on the same area of the wall, shall do extra over for the wall for fair face finished. So the area for the finish will be the same as the area for the wall. Then we shall deduct the last two items for this area. We shall deduct the area of the walls for and the fair finish. This area we shall deduct the area. What is this area? We want to find out what that area. You remember when we were finding the area of the walls, we have taken from out here to here to here to here, but we have the columns. The columns, we have already done them. So where we have the columns, we cannot do the walls. So for all the areas of the column, we have to subtract. We have to subtract to get the area of the walls. The walls, we are doing them all around. So we have this face of the column 200 and this other face 200. So we shall take 1, 2, 3, 4 columns times 2 faces, which are measuring 0.2, which is 200, by the height, that is 600. So that's why we shall take 8 sides measuring 0.2, 3.6. We shall deduct from the area of this one. Now we shall go to the parapet wall. Parapet wall. The parapet wall, we said it's this wall on top of the slab. This wall on top of the slab. What is the center line of the wall, so that we can multiply it by the height of the parapet wall to get the area of the parapet wall all around? The center line will be equal to the center line of the wall. We had already got the center line here because the center line of the parapet wall is the same as the center line of the wall below. So for the parapet wall, it shall be 24,200. Then the height of the parapet wall shall be, we shall come in to see it. Here it's 250 from here up to here. So we shall take the center line times 250 to get the top area of the parapet wall. We shall continue with the Pcc Coping. Sorry. So we were on the parapet wall, and we have said that the parapet wall, the length is 2.40 and the height is 0.25. 2.40 is the center line, and the height of the parapet wall, we are getting it from the section. The section says it 2.5. We go to the PCC coping. PCC coping is this part. So how do we measure it? PCC coping in the SMM, it should be measured in linear meters. When you are measuring it in linear meters and it's going all around the house, on the walls, it's all around the external walls, all around here. So how do we measure it? We shall take the center line. The center line was 2.40, so it shall be 2.40, 300 by 75 millimeters. PCC coping, once weathered, twice grouted, bended, jointed in cement. Ratio 1:3. Those are the instructions. The quantity survey is given. So go to the roof finishes. We're almost done. Roof finishes is, once we have constructed, we are following the section. We have already done the parapet wall and the PCC coping. Now we shall come to, and we already done the slab. We want to do the screed, then we want to do the asphalt. So what is the area for that? The area for the screed and the asphalt is the area inside the walls, the external walls. The area from here to here, from here to here, and from here to here, from here to here. So what is that area? That area, we shall get it from the plan. It is from here to here is 500 plus that 7,000 plus 200, 7,200. Then from here to here, it shall be 4,500. So it will be 7,200 by 4,200. So here we shall take 7.2 and 4.0. 50 millimeters average thick screed cement sand mortar 1:4 laid to fall on concrete slab, and 30 millimeters thick asphalt in 3 layers laid on screed. These descriptions, we are getting them from the section. The section here. Remember, every description, you should get it from the section. The section here, it states that this one is 50 millimeters cement sand, ratio 1:4 screed. On top of it, 30 millimeters thick asphalt finish. So now we shall go to the skirting. The skirting, it shall be this wall, and this wall that you can see, this to some is flooded on the slab. The walls cannot be destroyed. So what is the area of the skirting that we shall do? We shall do a query sheet. A query sheet will help us to answer questions. There is a question and an answer. What is the height of the skirting? The height of the skirting is 150 millimeters. What is the thickness of the skirting? 15 millimeters. So skirting is measured in linear meters. We remember we follow the rules in the SMM. So what is the length of the skirting? It shall be equal to the length 2 times the width 2 times. This length and width, they are the same as for the roof finish, because just adjacent to the length and the width, you see, here we have the slab, here we have the PCC coping. Inside, this height is 1 millimeters. Here it's where we do the skirting all around. So this one is 2 times length 2 times width, because we are measuring it in linear meters. The description: 150 by 15 millimeters thick skirting, and cut horizontally groove in wall for skirting. We have to cut the groove. That one involves some cost, so we need to we shall take it off. These same linear meters, we shall do the groove, so that when you go to the BQ, we can be able to account for it because it shall be costed. Then this one, build in edge of asphalt skirting and make it good. After we do the skirting with the screed, we shall come in with the asphalt to make it good. It shall be totally waterproof. We finish with the rainwater goods. The rainwater goods includes the downpipe and the neck and the shoe. So the downpipe, what is the height of the downpipe? The height of the downpipe, we shall take it from the section. From the section, you can see we have the downpipe is measuring from here at the floor level to here is 3600. You see the downpipe is from here to here. Then we have its height. It's from here to here. Here to here. That is 600. That is 600. Then we shall add some extension from here to here. You see it's 150. Then here it's a bit longer. It's not the normal. If it was straight like this, it would be 3600. So this 3600, we shall take 3600. Then we add this 150. Then we add another like 150 here to substitute for this length that is bending here. So it will be that 600 plus say 300. 300 includes these are 100. It shall be 3600 600 plus say 300, 3900. How many downpipes do we have there? Wherever we have these external, you see where we have the full borers, we have downpipe. We have 1, 2, 3, 4. So we have 1, 2, 3, 4 downpipes which measure 3.90. So when we are buying the downpipe, the length we shall use 3.90. Then the other one is detail but swan neck, say 600 millimeters projection, and ditto for shoes. We have the swan neck and the shoes. How many swan necks will we buy? The swan neck is this part and the shoe is this part. This part is the shoe. So how many do we have? Every down the that are equal to the downpipes. They are 1, 2, 3, 4. So now we finish with the full borer. We shall use some labor to do the holes for the full borers. You see this one? We shall use labor to do them, and also some UPVC pipe to do these holes. How many holes? 1, 2, 3, 4. So it shall be, sorry for God, we shall try to make our lives a bit accurate. So it shall be 4 times 1 in each, standard 100 millimeters, UPVC full borer, rainwater outlet, and there is some labor for dressing up the full borer with asphalt so that we can make it waterproof, so that water cannot leak inside. So they are 4. They are 1 each. How many? 4. How many? 4 water pipes. So we are done with the take off for superstructure works when we have the flat roof. I shall be able to scan this plan and the section for you so that you can be able to use it when you're revising that work. So kindly, if you haven't subscribed, please subscribe If you have any questions, kindly ask. We shall be able to answer. And in case you have any other thing that you would want us to discuss in these videos, kindly tell us. We shall be able to do it for you. So thanks for watching and have a good day.